Hello. Oh, got everybody's attention. Thank you so much for joining me today. My name is Peter Heinrich. I'm a developer evangelist with Amazon. You may actually ask what that even means. It's kind of a weird title. They certainly want to know when I go through TSA and they ask me like what I'm going to be doing in the country. But it's kind of a little bit tech support, some engineering, some marketing. Basically, if you're going to work with any kind of Amazon services or devices, then I'll be around to answer questions and hopefully point you at the right resources so that you can actually accomplish what you want to do. Maybe sometimes that means getting you sample code or actual hardware. You should hit me up afterwards. I can usually swing that. Generally, just trying to make it easy for you to do your work. Now, it happens that my background is actually in game development. I think my first GDC was 1996. So this is my 22nd, oh, really old. Oh, thanks. Yep, that's what I get for not dying. So the thing about it is that new technology still continues to get me excited. And if you heard about our big new announcement this morning, we have this brand new technology called Game On. And I'm super excited to talk about it, especially the nuts and bolts. That's the kind of thing that really I get into. I tend to geek out on the tech details. So hopefully you do too, because that's what this session is actually all about. I think showing code is the easiest way to kind of give you a flavor for the service, what it can do, and what it can do for you. Clicker. So Game On is actually part of Amazon's wider involvement in game services and game development. We have a lot going on, and we tend to call the whole collection of all those different products and services simply game tech. So that term describes the infrastructure that we provide, like game servers, analytics, even core backends actually through AWS, that kind of thing. The Alexa Skills Kit is another good example. It also includes some pre-built game services and tools, like GameLift or GameSparks, also development tools from Twitch Dev. And then there are resources for game content creation, and those include things like our free AAA game engine, Lumberyard. And finally, my group actually in particular focuses on distribution and marketing, which includes across Amazon.com, our Amazon App Store, and on Twitch. And Game On is a pre-built service that you can call from any device or operating system. So before I go any further, though, I just want to clarify something. So you hear those terms competitive play, community, and you just kind of naturally assume that esports is going to work its way into the conversation. This new service will help you with that. Whoops. But it's actually orthogonal to that space. It grew out of our experience with competitive PC games, many of which are immensely popular on esports, but the driving force was actually wanting to bring to mobile something that we thought was missing. So what is that? It's competition with something real at stake. Amazon Game On adds competition with digital and real-world prizes to any kind of game, no matter what the genre or category, and it's also cross-device and cross-platform. It does all the heavy lifting, which includes the setup and the execution, and fulfillment, which of course just means delivering all those prizes. And we make it easy for you to create and manage these one-off or time-bound competitions. You can also do multi-round competitions. So those are the kind where you have maybe a group of top players who succeed in one. They get invited to the next round, so you can continue the engagement. We also support league play and competitions limited to a specific locality, so a particular country or a GPS coordinate and a radius. So you could actually narrow it down to a specific city or even a neighborhood. You can also limit the interaction of players to competitions based on particular criteria that you set up, so you can have custom entry requirements. Of course, the driving interest for all these kinds of events are the prizes. It's your ability to award these actual, real-world, physical prizes. And if there's one thing that Amazon is actually kind of okay at, it's like delivering stuff. As Mari said earlier, it's how we're wired. We're definitely built to want to compete and compare ourselves to others. I also think we like to get packages in the mail. I just think that's the way at least that's the way I'm wired. So what does this actually look like, practically speaking? Well, you can check out a lot of great examples of Game On integration with our partners out at the Game On Lounge, which is right outside. For today, I thought it might be informative to show you how you could incorporate Game On into a simple game developed in Unity. So here's a game I want to upgrade, Super Zombie Runner, which, as you might imagine, is an infinite runner with zombies. Now, there's not too much to this game, obviously. You jump over some obstacles, you try to avoid getting trapped, and jump, yes. Oh, yeah, okay. So now I see my personal score after each run, but I want to add competitive play. So on the main menu, I'll add this option to join a tournament. Of course, those tournaments are going to be powered in the back end by Game On, and I throw up, as the developer, I throw up this screen to let the user know that they're in for competitive fun, and then show them the active competitions that I've set up for my game. They get to choose one, good choice, and this particular competition has a couple of real-world prizes. So now there's some incentive, right? And I'm sure I can do a lot better this time. I'm trying for that fidget spinner. Oh, well, okay, not so much. But this time I actually get to see a leaderboard. I get to see where I fit in the global categories, like how I'm competing against everybody else. I'm definitely incented, though, to do better. So I'm going to do my best this time, actually make it a little further, try to get the combo. Oh, not quite. There we go. Okay, got a combo. We're going. I think I can actually do one more combo before the end of this. Nope. It paused. Oh, no. Oh, that's so sad. Well, anyway, my perseverance pays off. I get to see the leaderboard. I get to actually win a prize. And when I claim it, it actually gets delivered to my doorstep. But I'm having technical difficulties. There we go. OK. So I mentioned before how competitive PC games helped inform our decision to create Amazon Game On in the first place. And it's pretty clear why. You look at this list, you can see that of the top 10 highest grossing PC titles in the US, 9 of them are actually considered competitive, according to some arbitrary definition. Really, just that they actively support player versus player gameplay, tournaments, brackets, league play, that kind of thing. And really, even the one that isn't marked there, Minecraft, I mean, I can understand why you might not consider it competitive in those according to that definition. But really, there's so many super fun third-party MOBAs that are built on top of Minecraft, I think it should get a mulligan there too. We also saw a lot of evidence that mobile games, even though they're not traditionally competitive in the same way that PC titles are, stood to gain just as much in popularity and engagement and revenue if they incorporated competition in a similar way. So there's nothing inherent about mobile that prevents that kind of success. So for example, this is some data on one popular mobile game that introduced tournament play. And you can see how there are several key indicators that significantly improve during their tournament week, with a spike in viewership on Twitch. Of course, that drives a bump in revenue early on, and that's followed by a healthy lift in downloads, which actually takes some time to decline again. So that's the rationale for Amazon Game On. Today, I want to give you the 10,000-foot view, just describe how to get started with the service, show some code for the typical use case, because that's the fun part, and touch on the operational aspect of managing competitions. So let's start with the high-level view. Amazon Game On offers 3 main areas of functionality related to competitive gaming. So competitive gaming on mobile is just incorporated into that. First, it allows you to easily set up competitions and define prizes. It manages all the details of the device registration and player authentication, including fraud prevention and abuse, identifying abuse. And finally, it also handles all the scorekeeping and entry requirements, and of course, the prize fulfillment component. Under the covers, Amazon Game On is a collection of web services running on AWS, so it's a robust, scalable, and reliable solution that performs well even under load. And it exposes a set of REST APIs that are accessible directly from client devices or from your back end if you want to do this from the server. The REST interface is what makes it platform and language agnostic. So any device or operating system capable of communicating over HTTPS can use Game On. We don't force you to use a specific SDK. I'm sure you heard Mario say, we got a lot of feedback saying that was not a desirable approach. So we don't force any particular library or service down your throat. You use whatever works for you in whatever language you like best. I actually use it from the bash command line, which is actually super handy for debugging and makes it easy to test out the service before you even write a single line of code. We also rely on, or I guess leverage, Amazon API Gateway, which is another AWS service, and it allows us to expose the service endpoint and define the interface, which means that you can use a third-party tool like Swagger.io to programmatically generate a bunch of model classes to interface with the API. And Swagger is great because it supports a lot of popular programming languages. It also supports a bunch of esoteric ones. So if you have a particular affinity for something unusual, you may actually be able to generate an API interface class directly out of the box. Of course, you can roll your own code as well, if you prefer. Today's examples won't actually depend on any programmatically generated code. I'm just going to whip up some samples from code of my own just to illustrate that it's not that difficult, but this is a really powerful approach. It's definitely worth looking into if you haven't tried it before. Okay, so how do you get started with Amazon Game On? Well, the first step is just to set yourself up as an Amazon developer. This is super simple. If you're already an Amazon customer, actually, you can log in to developer.amazon.com with your Amazon account. You can set up your own if you want, dedicated to development if you want to have a separate account. But either way, it only takes about 2 minutes and you're good to go. As an Amazon developer, you immediately gain access to our developer portal, which is where you enable services like Amazon Game On. You manage their settings there, and you obtain the security credentials you need to actually call the APIs from within your game. So after you let us know a few details about your game, like its title, its category, just as you would for submitting to any app store, you can turn on access to the Game On service. And when you do, we'll provide you with 3 special keys, which we'll also send an email. One is our own public encryption key, which you can use to encrypt data that you send to us when the service requires it to be secure. We sometimes refer to this as the game public key. Then there's the API access key, which is unique to your game. That you'll include in most requests that you submit to the Game On service during typical use, like when you're submitting player scores or retrieving leaderboards, that sort of thing. And finally, there's this companion API access key. That connects you to certain administrative functions that you don't normally use during regular gameplay, but I'll talk a little bit more about this later on. So you can enable and disable the Game On service for each of your games independently. You don't need to turn it on for everything. We will generate a unique set of those keys for each one, and this guarantees that some other developer won't accidentally or even intentionally submit their player data for your game or award your prizes to their players. Your game is the only one that can access its data. So here's our game. We've got the credentials we need for it to use Game On. And with those 3 keys in hand, we're ready to start making actual calls to the service. So as an aside, just to keep in mind, I want to make sure you know that everything I'm going to talk about, of course, is documented in depth on our developer portal. Once again, that's just developer.amazon.com. If you want to go to the Game On section, just add a /GameOn, and you can find everything you need to know about the service, about competitions, about prizes, setting them up, using the Game On console, and you also have access to our developer forum and a bunch of videos and sample code and that kind of thing. So the first step in using Amazon Game On is to establish a secure communication channel between your app or your backend and the service itself. Whenever a player connects to the service via your game from a device that we haven't seen before, we'll provide you with a unique token, which you should then store locally, and you want to keep private. It's something that you're going to submit with requests that you make to the service. How do we get it to you? The problem is that we provided you with our public encryption key, so you can send us encrypted messages, but it doesn't work the other way around. So to get around this, you need to generate a public-private key pair so that we can communicate securely in both directions. Although you should only have to do this once for each new device. So we can use the public key that you generate to encrypt a token that we generate for you, which you then decrypt with your private key from the pair. So you can use that token whenever you want to establish a new game on session from this device. Many frameworks, most operating systems actually have built-in routines and helper methods and utilities for working with public key encryption. But if you've never used them, then the process can be a little intimidating or confusing. So it's worth walking through the basic steps. First, just find out what's available, what kind of encryption utilities you have on your target device. Bouncy Castle is actually a really good third-party PKE library that you can use if you don't have the resources in the target device operating system. It's widely available on a bunch of different platforms. You want to use the tools, whatever they are, on your target to generate a 1024-bit RSA public-private key pair. Next, you're going to use the game public key that we sent you to encrypt the public key that you just generated. And then you're going to use the register API to send the encrypted public key to Amazon Game On. And here, I'm actually doing it from the command line, just as an example. You would obviously make usually you'd make a programmatic call. So we'll create a unique token for the current device. We'll then send it to you encrypted using the public key that you sent to us. You can then use your private key to decrypt that token. And once you have it, you need to make sure that no one else can snoop it when you send it to us, right? So you're going to encrypt it as a last step with the game public key that we sent you earlier. That will protect it from the eavesdroppers. And then once you have it in that encrypted payload form, you can store it locally and keep it for future use. So, like I said, it's not terribly complicated. There are several steps. If you haven't had to do it in the past, then it might be a little unfamiliar. But there's enough to it, though, that I did write a little helper class that I can use from Unity, since the game that I want to add Game On to is written in Unity. And it's just a wrapper for those bouncy castle calls that I mentioned earlier. Of course, you can substitute your own encryption library of choice. I highly recommend against rolling your own PKE code, though. It's kind of hard to get it right. So definitely rely on the professionals. In my case, Bouncy Castle makes it pretty easy. I use their public key factory to unpack the public key that I got from Game On in the first place. I store that for later use. And then I use the RSA key pair generator to spit out the public and private keys that I need. So this helper class actually has some additional methods to streamline the encryption steps of that key exchange. So when I need to encrypt the public key that we just generated before sending it to the service, and when we decrypt the token that we receive in return and then re-encrypt it for storage in the long term. And again, these are just some samples that I wanted to throw up to show you that it's really not, it's 3 lines of code, it's really not that difficult. And of course, all these resources will be available to you after the talk. So once we have that token, we can use it to initiate an actual Game On session whenever we want. We authenticate the current user to the service, and we receive a session ID in return. And so for the game code that we're looking at today, remember I mentioned we would not be using auto-generated classes. I just created some convenience methods here and there to pack and unpack our API calls over HTTPS. So for example, this authenticate method. And here's how the authentication works. First, I look in local storage to see if I have the token I need. And if not, then I go through that key exchange process that I just described. I give it a simple method called register. If that register call is successful, then I'll store the token locally, and I can proceed from there. And I created some classes to represent the Game On data model, which encapsulate the parameters that we send for each of the requests that we make to the API. So in this case, the auth player request object includes a parameter for the token that we need to send, as well as some fields for other data that the API expects us to provide. Now I can send the request to the game on service, and I pass some callbacks to process the response and deal with errors, if any occur. So if the call succeeds, we'll get this JSON block back, and I have a model class that knows how to instantiate itself from that JSON, giving me access to the data that it represents. And in the case of authentication, we especially care about the session ID, which we're going to use in subsequent calls. If it fails, no big deal. We can log the error message or display it or deal with it in some other way. Once we have that valid game on session, the player can now start interacting with actual competitions. So as I mentioned earlier, since Game On is an API and not an SDK, it's up to you how you want to present the key aspects of the service features. So for this simple Unity game, I added that tournament button to the main menu. When the player clicks it, an overlay appears. It just shows the active tournaments that I've set up, allowing the player to choose from between them based on these amazingly compelling titles that I've come up with. But this kind of UI is pretty trivial to create in Unity, so it's just up to us to retrieve the information from the game on service about which tournaments are actually available, and then use that information to generate the components for the display. So to retrieve that data, again, I've created this model to represent the action on Game On that we want to take, and in this case, it's retrieving the list of tournaments. It's derived from this generic request object that I defined that basically just stores the URI associated with it, doesn't do much else. The derived classes actually keep track of the specific data required for each type of request, which are named according to what Game On expects to see in the JSON body that we send to it. The constructor sets the URI corresponding to the REST API for this request, and then with the request object defined, I can again wrap the HTTPS communication call in some API-specific utility method. So I pass those callback actions for success and failure conditions, just as I did for authentication. And in this case, a successful call will return a list of tournament objects that were deserialized from the JSON response. Again, I've created a few classes to model the response and the tournament information that it contains. This is actually one of the, I'm going through this, I realized it is a supreme advantage of using something like Swagger to automatically generate all these classes. When you kind of tackle them all at once in a brief talk about a new service, it seems a little overwhelming, but the code itself is not too substantial. On the other hand, using a service like Swagger allows you to regenerate all these classes, on a moment's notice if something were to change in the API. Maybe reduces the chances of typos. So it's something to consider. For this call, we're just going to get a bunch of data back for each active tournament. There's a lot of information we can display to the user, including the tournament title, the start and end dates, maybe even an image. And we can even show the potential prizes as well, although that's not available from this data block. We can use the unique ID associated with each tournament by Game On to retrieve additional details about each one of them. So if we wanted that extended data, we would just make another call to the Game On service. We'd process the response in a similar way to populate an object with additional tournament details. Notably, this block does include a list of prize bundles, which I've defined at the bottom there. And those just include things like the title and the description and that image. Everything we need to create an enticing, browsable catalog of all the tournaments that the player can choose from. Now when the player expresses an interest in a particular competition, we can create this detail page for it. So we can include the prizes that are available, and then I'll add this prominent play button so that they can just dive right in. To actually enter the tournament, we need to add the player to a match. So if we look at the typical interaction model, we've reached this point, basically where the player has chosen to join the competition, and then calling the API in essentially the same way as we did previously, we'll post to enter the competition specified by the tournament ID, passing along the current session ID as well. Now, if successful, Game On will return a match ID, which indicates that the player has been admitted to the competition, and we can now submit scores on their behalf. Now, the game takes its normal course, the player plays, we track their performance, and when we consider their attempt complete, whatever that means, whether they've finished a level or they've lost a life, or they've achieved some status, whatever we've set up for them to do. Once they've done that and we can score their activity, then we'll post that score back to the service using the same match ID that we received earlier. Now for this example, I've created this screen in Unity to show the player's current standing after each run. And it's just a simple leaderboard in this case, but obviously we can combine this data with other details about the competition if we wanted. Game On allows us to limit how much leaderboard information we get back, so we can page through results if there are a ton of players. We can also specify how many other players we see that are close in rank to the current player's score. That data that we receive will include the name and the rank and the high score for the match leaders, as well as the current player and their close neighbors. So we can add all this data to the UI, and then depending on how you set up your competition, the player may be allowed to submit multiple scores, each one of which is considered an attempt. If the player hasn't used up all their allowed attempts yet, then we'll make sure that they can jump right back into the action and try again. So here's where we just were. The current player played one match, we submitted their score, and then retrieved the competition leaderboard to show their standing. Now, as long as the player has attempts remaining, we can continue the sequence as long as they want. We can play, submit a score, show standing, play, submit a score, show standing. And the original match ID is how the Game On service keeps track of those attempts. So the match ID returned when a player does successfully enter competition is good for as long as they want to participate in that competition. So each time you submit a score on the player's behalf, you should provide that original match ID. When you, as a developer, set up a competition, you can define the maximum number of match attempts allowed for any single player. And when those run out, no more scores will be accepted for that player. You can actually selectively add additional attempts to that, on their behalf, so they have more available, which is something that you may want to do in response to a particular achievement. For instance, if they reach a certain level, maybe you give them a few more attempts to get a little further. You should note that there actually are two different APIs that you want to call when you are entering a tournament, essentially differentiating between the very first time you enter and subsequent replays. And it's a pretty minor detail, but it's a way for us to keep track of when somebody is coming to the competition for the very first time. So once a competition expires, or you terminate it manually, Game On calculates the winners and awards the prizes automatically as appropriate. It hands out, it hands out the prizes to the top players based on how you define your competition, which means whether you have 2 prizes available or 10 prizes available, it'll automatically figure out who the top placers are. And you can see which prizes have been awarded to the current player by retrieving match details using that original match ID. So by now, more code. It's a pretty familiar pattern. You have this object request that encapsulates the request and the parameters that are appropriate to the API call. In this case, the important detail is the match ID. And then the companion method just wraps the communication over HTTPS to handle the packing and unpacking. The getMatchDetails response object in this example actually includes a lot of information about the player's current progress in competition, including, if the competition is complete, the details about the prizes they've actually been awarded. These are not necessarily prizes that they've claimed. They aren't considered to be delivered automatically. Game On requires that you explicitly report when a player claims an awarded prize. And this is to give you the opportunity to record the entitlement yourself when appropriate, such as when you want to give them something from your in-app catalog, as an example, or deliver a digital asset that you control access to. Also, for physical prizes, it provides a safety, right? You don't want to be delivering things that they don't actually want, although I can't imagine anybody not wanting a physical thing delivered. That would be kind of a fun prize. That seems crazy, but you definitely want to have that stopgap measure to prevent that from happening by mistake. So whenever you offer real-world physical prizes or in-app items, you want to give them the opportunity to see what they've won and actually explicitly accept the prize, officially accept the prize. So the REST API allows multiple prizes to be claimed at once. They can kind accumulate prizes, and then you can have them accept them all at once or individually. You just have to supply a list of the awarded prize IDs. And then the response you get will receive a list of all the prizes that were successfully marked as claimed, as well as those that couldn't be claimed for some reason. So, how do you actually go about setting up one of these live competitions? There are currently 3 different ways to set up competitive events in your game, starting with the game on console, which is on our developer portal. And it's the primary interface that most developers are probably going to use when they want to manage competitions on the game on service. It's a fairly straightforward, simple user interface. It makes it easy for you or your community manager or your producer to set up events and create prizes and review reports on your game on integration. There's also a separate administrative REST API, a companion interface actually to the one that I just described for use in-game. Earlier I mentioned how one of those security keys that we generate on your behalf will unlock features that you don't normally use during regular gameplay. Those features are part of this admin API. And it allows you to programmatically create and manage competitions and prizes when you're within your game, which can be handy if you want to run repeating events or if you regularly deal with lots and lots of events at once. And then finally, there's another option based on a powerful feature that I didn't demonstrate in my little Unity game, but you can enable player-generated competitions as well, giving your users the ability to stand up ad hoc events and invite others to compete. So these player competitions are functionally equivalent to the ones that you create as a developer with a few restrictions, like they can't attach prizes, for instance, or specify complex entry requirements. They can, however, make their events private, which is nice. That will cause Game On to generate an access code that they can then share with their family and friends. So they can have non-public events that they participate in. And this is really helpful for streamers if you happen to have streamers playing your games, because that lets them set up these custom events for their fans and their followers. And it's a great way for them to interact with their fans and get the word out about your game as well, which is always good when you're trying to build momentum. So of those 3 options, as I mentioned, the game on console is probably the most common way that you'll interact with competitions that you create for your players. And it's got a very straightforward interface. It makes it easy for anyone on your team to set up events. You can set time limits or add restrictions. You can monitor the leaderboards or check prize delivery activity. Any operational task that you might want to perform with respect to Game On competitions can be handled from this console. If you do have a community manager, it gives them the ability to manage and deal with all the competitive gaming in your game, competitive gaming in your game without the need for any kind of developer support. So just to give you an idea of how you might accomplish one of these tasks, the tournament details section of each competition that you set up, you have the option to make it recurring, which means that you can set it up so that it will reset on a regular basis. That allows players to rejoin. Whether or not they won or lost the last time, they can try again and compete again for the same set of prizes, which is handy since you don't then have to set up or manually re-enter all of that competition data every week if you have a weekly competition or every month. This is also where you would control the entry requirements that I mentioned earlier. So by default, anybody can join any of your competitions, but you can restrict access according to the country or the GPS location as I described, or the custom criteria that you set up. So in this case, I've changed the player eligibility to allow competitors from 3 specific countries. And if someone outside of the US or the UK or India were to try to enter your competition, they wouldn't actually be allowed to join a match. This also applies if you restrict access to some radius around a GPS location or require participants to satisfy some list of custom requirements. It's like, I don't know, having a certain minimum score, or I think somebody mentioned earlier, like whether or not you've set up an avatar picture or something like that, or if they have a particular inventory item. Those are completely up to you. You can really tailor the entry requirements to your particular needs. The Game On console also is where you'll set up the real-world prizes that you want to award your winning players. And again, these are items that are sold or fulfilled by Amazon, so you'll have to choose from, I don't know, like tens of millions of items. I'm not sure exactly how many are actually up there, but if you don't find a suitable prize on Amazon that you want to send, please let me know. You'll have my email at the end because I'm really curious what kind of prizes you're looking for. So that's a game on console, which, as I said, is probably the typical way that you would interact with your game on configuration. There are cases, I think, that you might want to create tournaments or tournament series from code. So I didn't really talk about tournament series. Specifically, they're those multi-round tournaments that I described earlier, for example, where only the top finishers advance. But regardless, for those situations, you can use this admin API. And it basically exposes all of the functionality of the game on console to your code, so you can do all that configuration programmatically. And like I said, this isn't required at all, and most games won't use it, but it is just one more option for controlling how the game on service operates inside your game. And that's it for my whirlwind introduction to Amazon's brand new game on service. Where do we go from here? Well, if I've piqued your interest at all in competitive gaming and you're interested in learning more, please join us for our panels. In this room, later this afternoon, we'll be discussing the future of esports with some industry insiders. We'll also be talking about the changing landscape and navigating it from an indie perspective. I also encourage you to visit our AWS booth on the expo floor. You can get a more holistic view of all the different web services that we offer in the service of games. And of course, I mentioned our developer portal, where you'll find tons of documentation about this service and all of our others, as well as programming examples and sample apps and hardware specs and all that other good stuff. And finally, please feel free to connect. Part of that involves responding to our survey on how we're doing and what resonated with you and what. So any kind of constructive criticism that you can provide on any of our talks is welcome, especially the ones that I'm giving. And I'm also happy to chat. Whoops, darn it, let me put it back. I'm also happy to chat afterwards if you have specific questions. We've got a lot of the engineers from the development team for Game On actually in the room. So if you have specific questions about any aspect of the technology, please don't hesitate to come up to the front and we'll try to get those questions answered for you. Thank you very much. Oh, one last thing. If you haven't seen these little cards, you can get one at the front desk or the desk right outside. There are 3 little circles, and you get a stamp for each one of these talks that you attend. If you go with all three of these stamped, you take it to the Amazon booth on the expo floor, you get a $20 Amazon gift card. So it's worth getting your stamps, I'm just saying. Thank you.